Question number 5. A continuous random variable x has a cumulative distribution function, CDF function, f of x is given as x less than 3, 0, 3 to 4, 1 by 6 into x minus 3 whole square, 4 to c, x by 3 minus 7 by 6. Show that the first question is, so that c is equal to 6. Show that the value of c is equal to 6. Okay. How will you show this? C as 6. How will you show that c is equal to 6? Anyway, we have few unknowns. One is c and one is d. One is c and one is d. So we know that once it reaches to 7, the total probability is reaching to 1. So capital F of 7, we already know that it is 1. So 1 minus 1 by 6 into d minus 7 whole square is equal to 1. Therefore, 1 by 6 into d minus 7 whole square is equal to 0. Or d minus 7 whole square is equal to 0, or d has to be 7. So we got that unknown, one value of d, we got it as one value of unknown we got, that is 7. Now, we know that the value of this cumulative distribution function from 4 to c is x by 3 minus 7 by 6. And from c to 7, it is 1 minus 1 by 6 into d minus x whole square. So you can calculate the value of f of c using the same two different equations. First, you can substitute this c here in this equation. So what is f of c? It is c by 3 minus 7 by 6. In the second equation, if you are placing f of 3, so what happens? 1 minus 1 by 6 into d value, we know that is 7. 7 minus c whole square. Both will be exactly c. So c by 3 minus 7 by 6 is equal to 1 minus 1 by 6 into 7 by 7 minus c whole square. So please try to make c the subject. So this becomes 6c minus 21 by 18 is equal to 6 minus 7 minus c whole square divided by 6. Now, from this numerator, we can take 3 common. 3 into 2c minus 7 divided by, this is 3 times 6 is equal to 6 minus 7 minus c whole square by, this is 3 times 2. Or no need of that, because we can just keep it as 6 itself. From the numerator part, we can cancel 6 and 6. 3 and 3 got cancelled. We got 2c minus 7 is equal to 6 minus 7 minus c whole square. So 2c minus 7 is equal to 6 minus, expand the bracket, 7 minus c whole square is 49 minus 14c plus c square. So 2c minus 7 is equal to 6 minus 49 plus 14c minus c square. So you bring all the terms to one side so that it becomes a beautiful quadratic equation. So it becomes c square plus 2c minus 14c minus 7 minus 6 plus 49 is equal to 0. So it becomes eventually c square minus 12c. Then minus 7 plus minus 6 plus 49 is plus 36 is equal to 0. So if you are making a completing the square, so it becomes c minus 6 whole square minus 36 plus 36 is equal to 0. So c minus 6 whole square is equal to 0. That implies as c is equal to 6. Hence, short. Hence, we showed C value is equal to 6. Hope you got it. Now, B part of this question. Find what is the probability of X greater than 3.5. So where is this X greater than 3.5? Where this 3.5 lies? 3.5 lies in between 3 to 4. So what is the probability of X greater than 3.5? So probability of X greater than 3.5 is, it's 1 minus probability of X less than or equal to 3.5. So in which one we will be placing this 3.5, because X less than or equal to 3.5 means we have to place in this equation. So P of X less than or equal to 3.5 means it is F of 3.5. That is the advantage of the cumulative distribution function. So 1 by 6 into 3.5 minus 3 whole square. So 1 by 6 into 0.5 whole square means it is 1 by 4. So that is 1 by 24. So substitute it. 1 minus 1 by 24. So 1 minus 1 by 24 is 23 by 24. So we got the answer for that as well. Correct? So 1 minus 1 by 24, that is 23 by 24. Now, this is a conditional probability question. What is that? Find the probability that, what is the probability of X greater than 4.5? Such that, given that it is happening between 3.5 to 5.5. So, first of all, you calculate this conditional probability. They will just write the equation for this. So, see question. So, what is the probability of X greater than 4.5 given that it is in between 3.5 to 5.5. So, note, what is probability of A given B? Probability of A given B is probability of A intersection B by probability of B. So this is our event A, this is our event B, correct? So probability of X greater than 4.5 intersection 3.5 to X less than 5.5 divided by probability of X is in between 3.5 to 5.5. So this is the idea. So probability of X greater than 4.5. Probability of X greater than 4.5. So 4.5 is definitely in between 4 and 6. And it is in between greater than, probability of X greater than 4.5, but it is given that it is in between 3.5 to 5.5. So the idea is very simple. That means this is our X values. So 3.5 to 5.5, and this is 4.5. Correct. So what is common? Because usually we need to find the intersection. Intersection means it is common. X greater than 4.5 means X greater than 4.5 means this part. And it is in between, given that it is in between 3.5 to 5.5. So that means the common region is this. So the common region is probability of X in between 5.5 to 4.5. So how will you find this probability? Probability of X in between 4.5 and 5.5. Definitely that lies in which region? 4 to 6. So if you want to find this probability, that is F of 5.5 minus F of 4.5. That is the advantage of this cumulative distribution function, because if you want to find that probability, you just substitute this f of 5.5 minus f of 4.5. So what is the equation of f of x in that particular region? What is that equation? See this, x by 3 minus 7 by 6. X by 3 minus 7 by 6. So x by 3 means x is 5.5. So I'm just calculating first f of 5.5. So 5.5 by 3 minus 7 by 6. What is f of 4.5? That is 4.5 by 3 minus 7 by 6. So substitute this value. 5.5 by 3 minus 7 by 6 minus 4.5 by 3 minus 7 by 6. So if you're substituting these values, and what we will get, what is that value we will get? That is 1.5 divided by 3. So that is half. So that probability is actually half. Yes. Now, what is the probability in between 3.5 to 5.5? 3.5 to 5.5. Probability of x in between 3.5 to 5.5. Here, if you want to find that probability from 3.5 to 5.5, see this. 3.5 to 5.5 means some part, because we already know what is the probability of x less than 3.5, and we already know what is probability of x greater than 5.5. It's not given, right? So it's not okay. So that is not given. So we have to separately calculate. So please calculate it. Probability of x in between 3.5 to 5.5. So probability of x to 3.5 to 4 plus probability of x in between 4 to 5.5. 4 to 5.5. So this is probability of 4 minus probability of 3.5, not probability of, sorry. This is cumulative distribution function of 4 minus 3.5 plus probability of 5.5 minus f of 4. So f of 4 and minus f of 4 got cancelled. So it is actually f of 5.5 minus f of 3.5. So f of 5.5 means 5.5 by 3 minus 7 by 6 minus f of 3.5 is 1 by 6 into 3.5 minus 3 whole square. So 5.5 divided by 3 minus 7 by 6 minus 3.5 minus 3 is 0.5 whole square divided by 1 by 24. And that we will get it as 5 by 8. Therefore, probability of x greater than 4.5, given that it is in between 3.5 to 5.5, is equal to, what is the common region? That is 1 by 2 divided by 5 by 8. So 1 by 2 divided by 5 by 8. So if you are simplifying, you will get it as 8 by 15. So that is the answer for this question.